Hey, what's up, Bulldogs? I am going to review very quickly here. Where is it? Parallel lines, parallel lines. All right, so in red, I am going to plot the point negative 3, 2, negative 3, 2, 1, 2, 3, 1, 2, and then 0, 4, 0, 1, 2, 3, 4. And as you can see, I've got some other points there. I make a line, and very quickly you should see that this is a parallel line, meaning that they're never going to touch these two lines. This will go on and on forever, as will this, and they will never intersect. They're parallel lines. So I'm going to take this point right here, negative 3, 2, and 0, 4, and I'm going to put it right here, negative 3, 2, 0, 4. I'm going to find, it's asking me to do this in slope intercept form, and there's a reason for it. They want to make comparisons. Let's take a look. So slope is y2 minus y1 over x2 minus x1. So slope equals 4 minus 2 over 0 minus a negative 3 equals 4 minus 2 is 2. And maybe, or maybe not, hopefully you do know that 0 minus negative 3 is actually plus. And you end up with 2 over 3, 2/3. That's your slope. I'm now going to use this point here and get myself a slope intercept. There's my slope. There's my intercept equation. Plug in 4. 4 equals, slope is 2/3. Not that it matters because we're going to multiply by 0. See that? 0. Use that 4 over there. 0 plus b. 2/3 times 0 is 0. 4 equals b. I'm then going to finish up my linear equation. I don't actually want anything for x and y. I just want a slope and a y-intercept. So y equals 2/3 x plus 4. That is my slope-intercept form. I'm going to plot that down over here on the red line. Y equals 2/3 x plus 4. There it is. And you'll quickly see that this is parallel to the B line, right? We said that? B line? Red and B line? What do you notice about the red line and the B line? Well, I'm going to tell you right now, they have the same slope. And that is the thing about parallel lines. They have the same slope. Different y-intercepts, as you can see. The red line has intercept of 4, and the B has the intercept of negative 2. So what does that mean? Well, I would like you to do the brown line, right? I want you to plot the points of the brown line right here. And then use green to plot these coordinates, these points. And you should find parallel lines. And what you're going to quickly find, this will be the brown line, y equals negative 2/5 x minus 3. Y equals negative 2/5 x minus 3. And what's the slope? Up, lo and behold, the slope is the same in the parallel lines. And you should have a line, a brown line, parallel to A. So I'll just make this brown, and I'll go, and you should have a line that's parallel to that. Finally, the green line, you should end up with a slope-intercept form of y equals negative 3x plus 4, y equals negative 3x plus 4. And what do you find? Very quickly, you find that the slopes are the same. Y-intercepts are different. Slopes are the same. So let's ask some questions. What do you notice about the slopes in each pair of equations? They are same slopes. How about the y-intercepts? They are different. Okay? You can pause this and think about that for a second. Make sure you do the work. What general statement can you make about the equations of parallel lines? Slopes are the same. Y-intercepts are different. So answer the following questions. Are y equals 3x plus 7 and y equals 3x minus 8 parallel to each other? Well, I think the answer is yes. And going forward, are y equals 2/3 x and y equals 3/2 x plus 1 parallel? I believe they are not, because they are different slopes. Name 3 lines that are parallel to each other. 2y equals 2x minus 3. I'm going to rewrite my slope-intercept form with different y-intercepts. Different y-intercepts. But the slopes are all going to be the same. That's the thing with parallel lines. Got it? Here, name 3 lines that are not parallel. Just change the slope, and you're all set. That's it. Change the slope. That means lines will definitely connect. They will cross each other. They will intersect, I should say. All right. So that's parallel. Let's go to perpendicular real quick. Here we go. So blue line. 0, 2, 2, negative 1. 0, 2, 2, negative 1. There you go. 0, 2, 2, negative 1. So what do? I find the slope. 2, 2 minus a negative 1 is 2 plus 1. And then 0 minus 2 is negative 2. You wind up getting a slope of negative 3/2 right over there. Then I'm going to choose the point 0, 2, and I'm going to find a y-intercept. 2, that's the y, so I'll just label this as x and y. 2 equals the slope, negative 3/2 times x, which is 0, plus b. Suddenly we realized that b equals 2. And you can see that anyway over here. B equals 2, the y-intercept, because x equals 0. You always know the y-intercept when x equals 0, and vice versa. Anyway, my slope-intercept equation ends up, again, no x's and y's, because there are billions and trillions and infinite number of solutions to these linear equations. Y equals the slope, negative 3/2, x plus 2, which is the y-intercept that we found. I'm going to take this, and I'm going to put it down, y equals negative 3/2 x plus 2, y equals negative 3/2 x plus 2, and I'm going to put it next to the line that it's perpendicular to. Which one is it perpendicular to? B. And perpendicular means that there's a 90-degree angle right there, just like that. 90 degree. See that? Think of a wall that's meeting a ceiling, or a wall that's meeting a floor. Those intersect at 90-degree angles. That's perpendicular. So the blue line, this blue line right here, is perpendicular to B. Blue and B, blue and B, blue and B. So what is the B? What is the B? The linear equation, slope-intercept form? It's right here. How about the blue? That's right here. And what do you notice? Well, here's the money answer. Ready? The slopes are opposite. So one's negative, one's positive. And they are reciprocal. So negative 3/2. What is? Find that. What is opposite and reciprocal of negative 3/2? Well, it is. Flip it over, 2/3, and it's positive. And those are the slopes of perpendicular lines. They are opposite and reciprocal. Opposite and reciprocal. So you'll do a couple more lines, and you'll find that the purple and letter C, purple and letter C, purple and letter C, right over here. Y equals 1/3 x, and y equals negative 3/1x. 1/3 versus negative 3/1, or negative 3. Those slopes are also opposite and reciprocal. And then finally, the what is this? Gold. Gold is perpendicular to letter A. Gold is perpendicular to letter A. Y equals 5/2 x minus 10. Y equals 5/2 x minus 10. And line A is negative 2/5 x plus 1. So again, the 5/2 and the negative 2/5 are opposite and reciprocal. And that's the thing about perpendicular lines. Their slopes are opposite and reciprocal. So I want to come over here and answer some questions. What do you notice about the slopes in each pair of equations? They are opposite and reciprocal. Opposite and reciprocal. So for example, let's do this one, ready? 2/7, the opposite and reciprocal of that is negative 7/2. Okay? What do you notice about the y-intercepts? I'm going to tell you right now, nothing. Okay? There's nothing there because you can actually have perpendicular lines on the y-axis. So there's nothing here. What general statement can you make about the equations of perpendicular lines? That the slope is opposite and reciprocal. So let's take a look here. Y equals 3x plus 7 and y equals 3x minus 8. I see 3 and I see 3. Are they perpendicular? Nope. And then, let's change colors here, make it exciting. Y equals 2/3 and negative 3/2. Yes, these are perpendicular. Name 3 lines that are perpendicular. So they have 2x. Notice every single one of my slopes is a negative 1/2. And then name 3 lines that are not perpendicular to 5x. Just make sure that it's not negative and it's not reciprocal. So anything would work except for negative 1/5, because that does happen to be opposite and reciprocal, and that would not work because they're looking for not perpendicular. Folks, that's it. I hope this helps you out. Have a great weekend. See ya.